This is just to take care for your radiation later on. Now this is how the antenna looks like. So this is nothing but, you can see driven element, where you can see this inside, right? That is nothing but where is the cable connection done, and this is the rod from that the wire will come down to the receiver. Now it is right on top. Okay, so there is a reflector which is present, which intercepts that power and radiation, and then there are multiple detectors. You can see there are how many detectors? 7, 8, right? So 8. So it's normally a 10 element Yagi antenna, right? Because there are 8 detectors, 1 driven element and a 1 reflector. Now this reflector also, you may say there are different rods, right? It's not that a reflector is a 3 times, no. Sometimes when you design the reflector, it may be a multiple sort of reflector, single reflector, and there are different configuration of a reflector also. So you may see in this figure there are 3 rods. It's not like the 3 rods are defining 3 reflectors, no, it's only 1, but it is added in some form so that there is a more radiation. So these are certain cases of Yagi antenna where you can define the radiator differently, reflector differently, driven element differently, and so on. So what will be the radiation pattern of this antenna? How it will direct? There will be main lobe on this side, side lobes, and a back lobe behind this reflector. So exactly the radiation pattern will look like this. Okay, exactly like this. You can just see. This is how the antenna is placed. This is how the radiation pattern will look like. If I place this antenna vertical like this, what will happen to this? This will also shift like a vertical beam. So you can see this figure. This I put because just to show you all how the reflectors configuration looks like here also. Okay, so it's a different reflectors can be used, right? So this is nothing but a broadband Yagi Uda antenna for a broadband connection. You can see how the dipoles are placed. You know, it is like a crossed fashion. Although I told you it is a straight line parallel, right? But now there are different modifications which has come up because researchers have found that okay, if I use a crossed dipole, it gives me a better result, it gives me a better gain, it gives me a better directivity. The radiation pattern is more smooth. I'm not getting more side lobes. Okay, I'm just getting a major lobe what is required. So as the research progresses, the antenna configuration also changes. So this is one of the antenna. You can see it's a 11 element antenna, right? You can see the dipoles how they are changed. Now if I see this, you can see just parallel poles are present, correct? You can see here these are the crossed ones. So you might have seen a configuration which is different than this, but a normal configuration of Yagi Uda antenna will be sort of this. Okay, there will be some directors, one reflector, and the driven element. So anywhere if you see the structure of the antenna something like this, it is nothing but the Yagi antenna. Now these are the general characteristics of Yagi antenna. You know, it actually, a simple Yagi antenna can work with just 3 elements, one reflector, one driven, one director. Okay, and if you want to increase the beam pattern and anything, so a more sort of elements can be added. It has a unidirectional beam. Unidirectional beam basically means what? Something like this. This is unidirectional. Bidirectional means what happened? There will be beam behind also, right? So we have seen, right? Unidirectional, bidirectional, etc. And it can be very well made up of lightweight because we are simply using aluminum rods. The cost is very less. We have seen the antenna which is being designed, right? It is of around 800 rupees or something. We have designed this. Simplicity in feed system design, because normally what you have is a length, width, and directly place them antennas and fixed it together. It will give you the result. Fixed frequency operated unit, because why fixed? We cannot change the frequency, right? Because every time we change the frequency, the length, spacing will change because everything depends on lambda. So one frequency, one antenna it is. Okay, it is a frequency sensitive antenna with a bandwidth of 3%. Now what is this bandwidth? I will explain this in the next maybe next video. Now bandwidth is basically band of frequencies it can work. Now suppose I have designed antenna for 35 megahertz. It is supposed to work for 35 megahertz, but there is a bandwidth which is allocated. Bandwidth meaning a frequency of bands. Like suppose it will start working at 34 megahertz and it will work till 36 megahertz, being the center frequency as your design frequency 35 megahertz. So 34 to 36 megahertz is nothing but the bandwidth. Anything beyond that, the antenna will not work. So it's very sensitive, only 3% of bandwidth it can work. Okay, which is very much sufficient for a television transmission or anything which can be used by Yagi antennas. The gain of the antenna, it is measured in dBs. Gain of the antenna is measured in dBi, so please make a note here. It's not dB, sorry, it's dBi. It's 7 to 8 dBis. So when you go back and see the calculations of gain, when I calculate this for a Yagi antenna, I will get a gain of around 7 to 8, which is quite normal for this kind of antennas. The signal strength can be increased. Now you see why the number of directors are being increased. The signal strength can be increased by increasing the number of directors. So if I go on increasing the directors, what I will get? I will get more signal strength, and that is what is required nowadays, right? Because if the signal strength is down, I cannot communicate. So if you need a more signal strength, you need more number of directors, and that is the exact reason why the repeaters are used by many of these companies. These companies, they use Yagi-Uda structures. You may see the multiple directors in one line and placed on the roof of the building. But these buildings, they don't use it for television, but it is for your normal mobile communication. So this is about Yagi antenna. I'm sending one problem on the WhatsApp group. Try to solve this. You need to find the reflector length, driven element length and the director length and design the antenna for the same.